Hey everyone, welcome back. We are continuing on with laws of logarithms, and now we're putting them together in lesson 7 and combining them. So the product and quotient law combined with the power law. And we're going to redo example 1 to see how you could do that in a different way now that we know the power law, and that is we determine the value of yada yada by taking the coefficient in front of the log using our power law and putting it into the exponent on what's inside the log. So 3 log base 2 of p becomes log base 2 of p cubed. And you do the same thing with the other term, and we get that. Now we use our quotient law. We're subtracting 2 logs, so same as dividing within 1 log. Okay, now we're close, but we have p over q equals 8, and we want p cubed over q cubed. So what if we were to take this and cube both sides? Okay, let's do that. So we'd have p cubed over q cubed equals 8 cubed. Okay, well that would work. And 8 cubed is equal to 512. So let's replace that. Now we have log base 2 of 512. 512 as an exponent of 2 would be 2 to the 9, and therefore this equals 9. All right. Okay, that was okay, but I think I like the way we did it the first time better. Okay. Now, example number 2. Use the laws of logarithms to write yada yada as a single logarithm. So let's take a look at that. So it looks kind of confusing now because we've got fractions, we've got all sorts of stuff happening. But notice the logs and the base on the logs, both base A. That means we can use our product, quotient, power, well, the power rule we'd be able to use even if they weren't the same. So our power law, the only thing is to use our quotient law here, we're subtracting 2 logs, we can't really have these coefficients in front. So what we're going to have to do is move those back into the exponent. So it's going to become 16 to the exponent of 1/2 minus, and then this one would become log base A of 8 to the exponent of 1/3. All right, now we can simplify those probably before we combine these. 16 to the 1/2. 16 to the 1/2, that is like saying the square root of 16. Okay, so that could just be 4. Square root of 16 is 4. Minus an 8 to the 1/3. So let's think 8 to the 1/3 as a radical would be really the cube root of 8. And what's the cube root of 8? That would be 2. So log base A of 2. 2 cubed is 8, so therefore the cube root of 8 is 2. Okay, now it looks a lot better, doesn't it? So quotient law, we're subtracting 2 logs. So we are going to combine those into dividing within 1 log. So 4 divided by 2, that is going to be equal to 2. And there we go. Oh, why did I write that as a 2? Okay. You ever have your pencil get ahead of your brain, or your brain get ahead of your pencil, one of the two? Okay, so we have log base A of 2. Now they want us to evaluate that if A was equal to 32. So let's replace A with 32, and now we need to evaluate that. Now this one is a little bit trickier because we want to get 2 as, ideally, as 32 to some exponent, right? Now it's a little trickier because we're going from 32 back to 2. That is going to be a root of some sort. So what root would I have to do of 32 in order to get 2? So what number, if you think about this, if 32 was 2 to the 5th, I would have to do the 5th root of 32 to get 2. So the 5th root is the same as a fraction exponent, which would be 1/5. And therefore our answer would be 1/5. Now, let's say that's a little confusing, because it is. There's an alternative way to do this. Let's say we let 32, okay, so log base 32 of 2 equals some variable, doesn't matter what. Then we're going to change it to exponential form. So we would raise both sides to get rid of that log. So undo the log by doing the exponent. And we would now be in exponential form, which is 2 equals 32 to the x. All right, now exponential equation. We want to get the bases the same on both sides. We've got 2 and 32, so we're probably going to change them to base 2. So that would be 2 to the 5th. And then the x is outside, so we would do power of a power, multiply those. Now that the bases are the same, we have 1 power equals another power. The exponents will equal each other. So therefore we would have then divide by 5, 1/5. Okay, so it took a little longer, but when it gets complicated, that might actually end up being the way you need to do it. So whichever way works for you is good, but yeah, let's look at the next page. Okay, evaluate the following without the use of a calculator. Okay, so first one we wouldn't be able to anyways because there's x's involved, but 3 log x minus log x cubed. Now, notice there's no bases on the log. That must mean that this is a common logarithm and it has a base of 10. Okay, so you don't have to write the base 10s in there, just know in your head that that's what they are. All right, so if we are going to use quotient law, right, they're both base 10 and we're subtracting 2 logs, we would probably want to move this 3 back into the exponent, okay, because we can't use quotient law with that 3 out front. So that's going to become log x cubed, and then we have minus log x cubed. Okay, we could use quotient law and combine those, but let's use our brain here. Log x cubed minus log x cubed. What will that equal? Yeah, that's right. What's 5 minus 5? 0. What's 2 minus 2? 0. What's log x cubed minus log x cubed? 0. Yeah, good. Okay, B, 2 log 5 plus 2 log 2. Okay, both base 10 again. Common logarithm. We're adding this time, so we're going to use the product law, but we have 2's in front. Okay, so let's put those 2's back into the exponent, or we could factor them out as well. Okay, so we'd have log 2 squared for that second one. Now we can combine those, and when we do, I'm also going to write down what those equal. So 5 squared is going to be 25, and that, oh, why am I writing this as a quotient? Okay, so it's going to be 25, and then times 2 squared, which is 4. So we have 25 times 4, which is 100. Okay, so can we find the value of that logarithm? What was the base on the log again? If it's not written, it's 10. So if I can write 100 as 10 to some exponent, we could have log base 10 of, say, 10 squared is 100. Then that would just equal 2, the exponent. Good job. Okay, C, what do we got? Evaluate the following. Okay, something is just bouncing out at me on this one. 3, 27, 81. Those of you familiar with your powers, you should be saying, wow, those are all base 3. Okay, so let's, maybe not the wow part, right? But okay, so let's change 27 to 3 cubed. And then we still have the 3 outside of that. And 81, we're going to change to 3 to the 4, but again, there's still a 4 outside of that because we've only replaced 81, not 81 to the 4. Okay, so we should probably simplify this a little bit. So we're going to use power of a power, so 3 to the exponent 3 of 3 was going to be 3 to the 3 times 3, so 9. And on the bottom, we're going to have 3 to the 4 times 4, which is 16. Okay, just using exponent laws really now, aren't we? So 3 to the 9 divided by 3 to the 16. When you're dividing two powers, you subtract the exponents. So that would be 9 minus 16, which is negative 7. Ah, and there we go. The base on our power and the base on our log are the same, so therefore the log is the exponent. Good job. Okay, example number 4. Log base 2 of x equals a. Determine an expression for log base 2 of 16x squared. Okay, sometimes these are tricky because you don't know where to start, right? There is a couple ways you could do this. We could use log base 2 of x equals a and find what, say, x would equal and then sub it in over here. Or we could work with this and use our product law and power law and then sub in this where appropriate. So I don't know which way we should. I'll do both and then you guys decide which way you want to do. Okay, so let's say we work with the log base 2 of 16x squared. I'm going to do it over here. So we have two things being multiplied within a log, so I can write that as 16 and then plus log base 2 of 16 plus log base 2 of x squared. Okay, then also notice we have an exponent on something that we're logging. That could move down front. Why would we want to do that, you ask? Okay, so you didn't ask, I don't care, but maybe you did. I shouldn't be so callous. Okay, so we would want to, the reason why we want to do that is because we were given a log base 2 of x being equivalent to a. So log base 2 of x here could be replaced with a. So we'd have 2a. Oh, and then what can we do with this one? Log base 2 of 16. 16, always keep your eyes open for things that can be written as powers. Log base 2 of 2 to the 4. All right, so that means that that will just equal the exponent, which is 4. And there we go. There's our answer. 4 plus 2a would be our expression. Notice they said expression. That there, expression, implies that our answer won't be just a number. It's going to have a variable in it. Okay, so don't know if you like that way, but another way you could do it is come over here and we could work with this first, the log base 2 of x equals a, and we could change it into exponential form, get rid of the log, and we could have x equals 2 to the a. Then we could replace x in our log function, so 2 to the a, and then there's still an exponent of 2 outside that. And then we could work with that. So we'd have log base 2 of 16, I could write as 2 to the 4 times, and then this, use a power of a power rule here, so 2 to the 2a, a times 2, right? Then more exponent laws. We're multiplying two powers. The bases are the same. We could write that as adding the two exponents, so 4 plus 2a. And now we have log base 2 of 2 to the 4 plus the 2a. And therefore the bases on the log and the power are the same, so this is just equal to the exponent. All right, so I don't know, what do you think? I think this was less confusing, but if you would like to do it the other way, I'm okay with that as well. Okay, example number 5. Write the following expression, look at all those variables, holy cow, as a single logarithm. Okay, so first of all, take a look at the logs. Don't get overwhelmed by the question, okay? Look at the logs and look at the bases on the log. Notice they're all no bases, which means they're base 10. They're common logarithms. Okay, so they're all base 10. We're good to go to use all our laws. Now, we've got a lot of adding and subtracting logs, so we're probably going to be using product and quotient law. But we have some coefficients kind of blocking us on a few of those. So let's first write those using our power law with logs back into the exponent. So 5 goes back into the exponent on the e. Okay, and with the other term, the 1/2 is going to go back into the exponent on the a. Okay, all of our coefficients in front of the logs are now back in the exponents using our power law. And we can now combine things with our product and quotient law. So the terms with negative signs are basically going to be divided but multiplied together. Remember that factoring thing we did before on the bottom. Now, it's not the logs go to the bottom, okay, please? Because I know when it gets more complicated like this, people forget what they were doing. It's the thing inside the logs that go to the denominator. So e to the 5 and a squared both go down there. The rest of these all have positive signs, so that would be multiplying in the numerator. So we would have b times d times a to the 1/2. Now notice I'm not putting multiply signs. If you write variables next to each other, it means multiply. Okay, that's actually looking pretty good. Technically, it's a single logarithm right now. We should just look and see if we can simplify anything further. B, D, a to the 1/2, e to the 5th. Oh, look at our a's. Okay, so we have two powers that are both base a, and we're dividing them. So we could simplify that a little further. We could go b, d, and then subtract our exponents, and that would go in the numerator initially. So we'd have 1/2 minus 2 all over e to the 5. So I have basically divided my two powers with a, and that would be b, d, a to the negative 3/2. Okay, and then writing that without negative exponents, I would move that a term to the denominator, and I'd have log of b, d over e to the 5, a to the positive now 3/2. Okay, good job everyone. So we finished lesson 7, should be ready for the assignment, and thanks for watching.